Welcome, everyone. It's great to see so many of you today joining. And let's talk about what 0x Poland is. So we started 0x Poland with a goal to promote programming skills around Ethereum ecosystem and blockchain ecosystem as well. We want to grow Polish Ethereum community, and we want to invite as many people as possible to join this great adventure, which is being a blockchain developer, being an Ethereum developer, and building this wonderful stuff. So roughly a month ago, we put this billboard in one of underground stations on Politechnica metro station here in Warsaw. There was a puzzle to be solved. There was an address of the contract. There was some code. There was an award to be won. And I'm going to explain all about it by the end of the presentation to everyone who would like to know and understand why we put the puzzle there and how to solve it. So our goal with creating this puzzle to raise attention of developers community and tell people, hey, there is something very interesting going on in the blockchain space. And we're super happy to tell you that we did succeed in raising this attention, and we've been described in many places, and we've been mentioned on Spider's Web, on Just Join IT, BitHapel, but also not only in Poland, but in different places, in different news outlets in the world by very popular Decrypt. There was ongoing discussions on Reddit, on cryptos, even on 4chan or Weibo, which was a complete surprise to us. So what's coming? What's 0x Poland? So we're starting the season 1 today with the first meetup with episode 1. We plan 7 meetings in upcoming months. On second Tuesday of every month, we're gonna have 1 meetup. So December, January, all the way up to June. And we're gonna discuss all stuff regarding blockchain and specifically programming and coding and everything that relates to blockchain. So it's gonna be strictly technical meetings. And we especially invite everyone who's interested to join the space, everyone who's interested, okay, how is that exactly working? What is this blockchain all about? What are the smart contracts all about? And so on and so forth. So more than that, we're gonna have a workshop. So we're gonna have in January on 22nd and 23rd, we're gonna have a weekend workshop. So for everyone who would like to spend 2 days and get the initial understanding how to build smart contracts, that's a perfect workshop. And we're gonna have a student workshop that's gonna happen in March and April. And then we're gonna have another workshop in May. And in the season finale, we're gonna have a hackathon with awards, 2 days of hackings. That's gonna be May 29 and 30. And you can already subscribe to the first workshop, the January workshop. And I think here it is. You can see where to sign up. There's gonna be a limited amount of places. So make sure to subscribe as soon as possible. So if you want to stay up to date with us, go to 0xpoland.dev or just follow us on Twitter on under the handle 0xpoland. And I would like to make a shout out to our media partners, CryptoDev TV and Zrozumieć Bitcoina. Those are also great places to learn more about blockchain and Ethereum. And today we're gonna have 2 presentations. First one is gonna be, I'm gonna be doing the first one. It's gonna be called Down the Rabbit Hole. We're gonna explain blockchain basics. We're gonna write our first smart contracts. And most importantly, we're gonna solve the puzzle that was posted in underground, on the underground station last month. And that's gonna be a beginner track. We're gonna try always have beginner and advanced track. So there's something attractive for people who want to join the space, who want to start, learn more. And there's gonna be an advanced track for people who already know a little bit, know how to code, but would like to extend their skills and learn more. Today, the second presentation gonna be done by Leon. Leon, what's your name? Leon Lognikov, and he's from MakerDAO, and he's gonna explain you the basics of DeFi, and especially he's gonna explain how to build debt in code, how to code debt, and how does that compare to debt driven by our legal system. So without further ado, down the rabbit hole, let's start with explaining what the blockchain is. To understand what the blockchain is, one have to understand a little bit more about the innovation cycle, about disruptive technologies and how technologies are being born. They have their springs, they have their summers, they have their falls, and eventually they land on the graveyard of technology. So the disruptive technology notion was introduced by in the book called Innovator's Dilemma. What the book says is that innovations go through the cycle, and those disruptive technologies go through the cycles, and those disruptive technologies tend to change the world, tend to change the like empire's gonna grow and empire's gonna fall when new disruptive technology gonna show up. And one great example that everybody knows and is very familiar with is a smartphone. So a smartphone was one of the very first smartphones were created in Nokia and was called Nokia Communicator. And when it was created, it didn't make a lot of sense for many people, in a sense that Nokia Communicator was really big and heavy and was not really portable. And if you want to edit your spreadsheet, you had a spreadsheet application, but the screen was small, so you didn't really could do much editing of your big old spreadsheet on your small heavy phone. So for many, there was very few people who would actually spend tremendous amount of money just to buy this weird phone. But so in general, one could say it didn't make a lot of sense for the mainstream market for smartphone initially. But then as technology started improving, it was cheaper and better, the screens were bigger, and the battery, it was smaller, the battery was better, and so on and so forth. It turns out that suddenly everybody has an iPhone. And I can tell you that iPhone is only 12 years old. So it was like 15 years old that people were like, I remember myself because I was having a chat with my friend and he said, yeah, smartphone's gonna be everywhere. And I'm like, dude, this is heavy, this is expensive. My mother never gonna have a smartphone. And he says, no. It's gonna change, the screen's gonna get bigger. And that's exactly what happened. The funny and ironic fact is that Nokia was the company to bankrupt because of the smartphone revolution. And the funny thing is that that happens a lot. That happens a lot. For example, Kodak was the company that was the first one to create a digital camera, and digital camera was the reason why Kodak eventually went bankrupt. So, but empires fall, but empires come to power. Google or Apple are great examples. So if we look at these trajectories of how the products get developed over time and get better performance, we can see that initially it doesn't make a lot of sense for the consumer, for the mass market. And as it gets better, it suddenly, when it crosses the line and it makes sense for customer, for my market customer, then suddenly the adoption happens very quickly. In just a couple of years, everybody got the smartphone. And I think it's very important to understand that blockchain is getting really close. In many people's opinion, blockchain is getting really close to this position to make a lot of sense for mainstream market, which is a huge difference between just a couple of years ago when I was doing similar presentations and I was saying, yeah, this is still a couple of years ahead. And finally, those technologies progress up to a point that are more than good enough. Like smartphones, we don't know anymore. What's the difference between iPhone 10 and 11? If I would ask you, hey, what's the difference? Most of you wouldn't be able to tell the difference between iPhone 10 and 11. So when those disruptive technologies come, and there is a especially interesting category of disruptive technologies called computational platforms. So smartphone was not only disruptive technology, but a new computational platforms. It was slower by many means, and the screen was smaller, but it was not important that there were problems regarding, that it was not ready for the mainstream market. What was important that it was handy, there was a camera and GPS, so you could build new things that you could never build before. You could build Instagram, you could build Uber, something that wouldn't make any sense with previous generation of computational platforms like desktops. And the same with internet, right? To give you another example, there was in the 90s, the internet was slow. It was mostly used by academics, by the army, and like people were saying, the internet is full of pornography. You should probably not use internet. And in fact, there is an article about Amazon in 2002, I think, or 2003, it might have been that says Amazon is a scam. It's losing money. There is no future in the internet business. But what was not important is that the internet was not so good at the beginning. It was not so important that there was a bubble in the late 90s. What was important is that it has this instant access to information that allowed to build Amazon and Google and Netflix and all the other stuff. And here we finally come to cryptocurrencies and blockchain. What is the new feature that they have that nobody else has? It has a trust. It has a built-in trust. You don't have to trust an institution. You don't have to trust a person. You don't have to trust a judge. You don't need to build a law. It's enough that you trust the code and economy and the protocols, and you can build new stuff that you could never build before. What you can build is digital gold. You can build cash. You can build money on the blockchain. How does one do that? Well, let me explain a little bit more how the blockchain works. An easy way to think about blockchain is think about it as a great spreadsheet, like a huge Google spreadsheet. And it has only 3 columns, from, to, and value. And every time you issue a transaction, it's just a new row. So you can only add rows to the spreadsheet. You cannot delete rows. You cannot change things that are already in the spreadsheet. And there are some rules about the rows you can add. Let's call it consensus rules. So for example, in the spreadsheet, you cannot add a row that would represent a transaction that would be spending money that you don't have, or more money than you have. You cannot add a transaction that would spend the same money twice. And there is a rule that if I make transaction from person A to B, then the same amount of money is subtracted from one account and added to the second account. And that's very simple. And even with that simple notion, even with that weird new database, distributed database, you can build something pretty interesting. You can build digital gold. How does one do that? Well, throughout the history of civilization, it was always the thing that was the hardest to produce that would be used as a store of value. The way we see gold, the primary purpose of the gold today. So it was the stones in Rye that was super difficult to mine and then made into what they look like. And people will use it as a currency up until there was a great progress in civilization and someone wanted to buy and someone had a business in producing more of those stones. And with the new technologies and mining, they would basically destroy the economy of Rye stones and they would stop being currency. But they would be used for hundreds of years before. And similar story comes about seashells in Africa. And today, gold is still, we call it gold is a golden standard. We even say things are golden standard because gold is super difficult to mine. And in fact, it's such a good store of value that you could buy 200 years ago with a similar amount of gold. You could go and buy a dinner you can buy lunch in the restaurant, or you can buy a flat in the center of London. It's such a good store of value that, you can buy kind of the same things even with all the progress that we have in technology and civilization. And the other funny thing about gold is that there is a progress in mining gold. Their technology is getting better, but all the easily accessible gold is already mined. So it's harder and more expensive to mine gold because with better technologies, you need to access harder gold that is harder available. So it's amazing property of gold there is nothing ever that has there was nothing ever before that has a similar property. And in fact, there's something called stock to flow ratio, and stock to flow ratio is a measure how difficult, but also how many of the new thing is being produced versus what already exists. And gold, up until this year, gold has the best stock-to-flow ratio in the world. There was nothing in history of humankind that would have a better stock-to-flow ratio up until this year, when we have a halvening in Bitcoin, meaning that less Bitcoin is produced, and the best flow-to-stock ratio today is the best stock-to-flow ratio has Bitcoin, and it's going to get even better in 4 years, and it's going to surpass gold by far. And if you look at the rate of Bitcoin throughout the time, you can see that generally Bitcoin is growing in value. And this is not, by the way, by any means investment advice, but you know, like you hear about bubbles pop and so on and so forth. But if you look at the logarithmic scale, if you look at the long term, you can see the general trend is growth. So this is very, very unique and thing that, you know, the economical properties that we didn't see before. Now, so that was very simple. That was first blockchain, that was Bitcoin. Now we're gonna start trying building something more advanced. Let's talk about smart contracts. Well, to extend our analogy on the blockchain, you can think about smart contracts as a new addition to our spreadsheet. Now we can still add transactions, but we have a new kind of transaction. We can make a transaction that we don't address to any particular person. There is no value in the to column, but instead of value, we're sending a little bit of computer code. Let's call it a smart contract. And what happens is once the transaction is mined, it goes into a blockchain, the code stays there, and it gets its own address, like other users in the network. And once we have the address, we can send money from user to user, like we could in Bitcoin, but we can also send money to a smart contract, to a piece of code, and code can send money to us. And we can also send a transaction to code that's gonna trigger execution on any specific function. So in other words, now we have two kinds of animals in our blockchain zoo. We used to have just wallets. Wallets would have their addresses. I can send money to an address like I can to a bank account number. And each wallet has a balance in Ether, which is a cryptocurrency that runs on Ethereum, which is a blockchain that introduced smart contracts for the first time. But now we have a new animal called smart contracts. It's a piece of code, executable code. It can store information on the blockchain. And it's Turing complete, meaning you can write any program you can write in any language you can write in a smart contract. It's deterministic, meaning every single time we're going to execute a little bit of code on the smart contract on any computer in the world, it's going to work exactly the same and going to give exactly the same result. And here's another detail. You need to pay for every line of code, for every instruction of assembler, you need to pay for execution of the code, and you pay with gas, and you buy gas with Ether. That happens automatically. So you can think about paying for transaction in Ether. And how you write those smart contracts? Well, you use Solidity. How you use Solidity? Well, here's an example smart contract, a very simple one. It's basically the simplest smart contract you can think of. It's a simple storage. It just have one variable stored data. It's of the type integer, unsigned int in detail. And what it allows to do is just set the data. Where the data is stored? Where the data is stored on the blockchain. So every single full node of Ethereum gonna store the data. And this data can be set by anyone and can be read by anyone. And even such a simple smart contract, simple setter, simple getter, if you program in any language in your life, you probably understand what does this contract do. Well, the contract, you can think about contract as basically a class in object-oriented programming. And you can think there is a space of object that every single contract can talk to any other contract on Ethereum blockchain. And even such a simple contract have a very interesting property. I can leave a message for someone on the smart contract, and anyone in the world who have access to internet can read this message. It cannot be deleted. Like the whole history of what was said on the contract is available to anyone at any time. So that's very interesting property, because it would be super hard to be done without blockchain. Like any information I can put on the server is going to disappear the moment that the server goes down. This is gonna stay forever until the last Ethereum node is still running. Now, let's try something more complex. What could else I want to write on the blockchain? Well, there is this cryptocurrency called Ethereum, and we can use it to, do stuff, run execution of program. We can use it to trade. What if I want to create my own? Well, creating a blockchain is pretty difficult. You would need to do things like hire cryptography programmers, hire networking programmers, and you would need to build all the blockchain. But now with Ethereum, you don't need to do that. You can just create a smart contract that represents your new coin, your new currency. Well, how does one do that? Again, it's very simple. Let's examine the contract called coin. It has two variables, two information stored on the blockchain. One is minter, so the person who is allowed to create new coins. And there is a mapping or in other languages, you could call it map or dictionary or hash. That simply stores a very simple information. For every single address in the Ethereum network, we store the balance of that account, counted in, of course, our newly created coins. Now, if we go with our eyes a little bit lower into a constructor, all we do in constructor is says whoever deploys the contract, whoever creates the first transaction that puts the contract on the blockchain is the minter. And only minter, as we remember, will be able to mint new coins. And if we look a little bit lower again, there is a function called mint. It has two arguments: the receiver, the guy who's gonna get the money, and amount of money that he's gonna get. It's a public method, but if you look at so anyone can call the method, but if you look at the first line of the method, you will see of the function, you can see there is a require message sender to equal minter. So if it's gonna be called by someone else, then the minter, the person who originally created the smart contract, it will revert, and that transaction will not succeed, and therefore the money will not be printed, the function will fail. And there is a requirement, like we cannot mint too much money. But other than that, the program is very simple. We basically add the amount to the receiver balance, and that's it. And once if I am not a minter, if I'm a user of the contract, I need to use a function called send to send money to other people. All that is required is that I'm not sending them more money. If you look at the first line of the code of the function, you see that it is required that I have at least the amount of money that I want to send. And then it's very trivial. The logic of the smart contracts is very trivial. I'm just subtracting money from my account and adding the same amount of money to another person's account. And additionally, I'm emitting an event to inform the world that something had happened. Good. So this was a funny smart contract. I can create my own coin. Why would I do that? Why would I create my own coin? Well, here is an idea. How about I create a coin that is pegged to US dollar or any other really currency in the real world? And in fact, there is a company called Maker or Maker Foundation that created DAI. DAI is a dollar, is a cryptocurrency. It's a token. It's called ERC token. It lives on Ethereum, and it's pegged to US dollars. And the funny thing about DAI is you don't need to trust them. You don't need to trust the foundation. You don't need to trust institution. You don't need to trust US Treasury. The way it is built around smart contracts is there are economics incentives to make one DAI worth $1. So it works without anyone looking. And how does that happen exactly? All about that going to be explained by Leon in following presentation, the one after mine. So why would I have a dollar on the blockchain, one might ask? Well, it's easy to transfer, it's easy to manage. That's one reason. Another reason is there is the whole new thing called decentralized finance that happened, also DeFi, called just DeFi. And there is a lot of things you can do with those coins. And one thing you can do is you can lend them to other people. And again, you don't need to trust that people, you don't need to know that people, you don't need to trust the bank or anyone else. How does that work exactly? We're gonna learn soon. But by lending those tokens, I can earn money. So I can use my dollars, buy my DAI tokens, and put it in the smart contract. And this is a screenshot made a couple days ago, so it's pretty current. And it says I can earn 2.91% annually by doing that. So that's almost 3%. In comparison, if you go to any bank today, I have a premium account. I have an information from the bank that they have this super premium account for me, saving account with 0.01 interest percent. So 1 promille annual interest rates annually, right? So it's really not very attractive. Here in this blockchain space, we can see that you can have 3% on DAI. There are other stable coins like USD Coin, Tether that gives even more. So it's very interesting that there is this alternative economy, this new financial system happening in parallel to our existing system that offers very interesting services that you don't get in traditional financial system. And the whole DeFi thing didn't really exist 3 years ago. You can see it was basically worth zero. Maker is actually the first DeFi that was ever created. And I think it was around 3 years ago. And then, it was, for a year, it didn't really raise a lot of attention. And then 2 years ago, it started growing like crazy. And today we have $14 billion value locked. Again, it's a screenshot from just a couple days ago. So I think it's pretty current. We have a tremendous amount of money locked in the system, but super important is, like with Bitcoin, we are on exponential growth, meaning that it was zero just 3 years ago, close to zero 2 years ago. It took forever to get to 1 billion, and now I just checked a couple months ago, it was, I think, 2 billion then, and now it's 13 billion. So it's small, but it's growing really, really fast. Good. So as the last point for today, I would like to tell you how to solve the puzzle. Why we put this puzzle? Well, as I said, we put the puzzle because we want to raise people's attention. We want to say, hey, come to 0x Poland. There's something extremely interesting happening in the blockchain space. There's this whole DeFi thing happening. So, maybe it's something you want to do. Maybe it's something worth a little bit of your attention. So for that, we did this small PR stunt. That was the poster. So you can see there is an address of the contract, and we can, now that we know a little bit of Solidity, we can examine the contract. The contract called puzzle, you can see in the comment that there is a hint: find all 4 clues to solve the puzzle and claim the reward. The balance on the contract is 7 ETH. 7 ETH is worth, I think, a little bit more than 10,000 zloty as of today. I think more like 13, 14 maybe. And here's the contract. So to solve the puzzle, all you need to do, if you look at the line 33, all you need to do is call reveal function and provide the solution. Solution is of a type string. So it's basically just a string, just a sentence that you need to provide to solve it. And if you look at the line 41, if you provide a proper solution, we're gonna tell the contract have a winner variable, and we're gonna set it to message sender. And in line 42, we have a withdraw function that just checks if the message sender is the winner, and if so, it's transfer all the money that it has to the winner. Now, there are some complications. So first of all, we cannot show in the smart contract what the answer is, because if we would, then obviously we would not be able to. Then everybody could see the answer and provide the answer. So instead of storing the information about the solution, we store the hash. And the way the hash works, I guess every programmer knows, but it allows you to store the information without revealing what the information is. Well, or store information about the information so that when the information is provided, we can verify if it's the right information. So and then if you look at if you look at line 34 in reveal function, we calculate the hash of the solution, and then we look in line 39, we look if the solution is in fact the one that was hashed when the contract was created. Additionally, there is an attack on smart contracts called front running. So if I create a transaction and it has a solution and I send it to the network so that it can be mined, and when it's going to be mined, the function is called and the money is transferred or the winner variable is set, other people can look at what is being propagated on the network. They can look at what's called mempool. So they can look, what transactions are waiting to be mined but are not yet mined. Therefore, we require the winner to first commit a hash of the solution and couple blocks ahead of to prove they know the answer. And only when they provided the hash, commit the hash, and then they reveal the actual, they would win the reward. Now, if they provided a hash, then other people could front run their hash. So they have to hash both the answer concatenated with their address so that other people cannot front run them. And finally, we couldn't store the hash because people could see the hash. So we need to store the double hash. Good. So this is it. So there was a bunch of different tips. There was a bunch of different clues. So that was the first clues. It was published on our Twitter. It's lyrics from the song. The song is called Dark Forest, and Dark Forest could be capital, could be differently spelled. So we make sure that there is a regex in there is a small regex in the tweet that help people to format correctly the answer. And you can see there is a small hexadecimal string at the bottom. That one was used for checking if you get the right answer. If you calculate the hash of the answer, you could check if that was right by seeing the hash. And there would be another clue. That one was reference to Hitchhiker's Guide to the Galaxy, very classic science fiction novel. And the third one would refer you to a newspapers. If you find a newspapers, there would be a phone number. And the last clue was you could get the last clue by calling the phone number. And just, I think, 20 minutes after we post the last clue, there was a transaction coming with a solution. The solution was with 0 exponent into the dark forest, down the rabbit hole where adventure awaits. Good. So adventure awaits. If you have any questions, please let me know. I want to let you know that I want to remind you that there is a workshop coming, and feel free to subscribe to that.